Assalamualaikum and good day to everybody. This is the second part of our software testing video. In the previous video, we're actually covering on more on the foundation concept of the software testing, looking at verification and validation, inspection and software testing. And in this video, I'll be covering on the different type of testing that you can perform during development testing. Okay, so during the development of the system, testing can also be done. This is normally done by the development team. Okay, most probably the programmer. So the kind of testing that can be performed during the system development is unit testing, component testing, and system testing. Okay, with unit testing, you can actually test program units or the classes that are being developed. Okay, you are basically focusing on testing the functionality of the objects or the methods. Right, component testing is done on a collection of units or integrated or maybe there are some components. When I refer to components, basically it refers to a collection of objects, and maybe 2 or 3 components are integrated at this point of time. So you can perform testing on this. It's basically trying to test the component interfaces. Interfaces here is not referring to the graphical user interface. Okay, it's not. If you still remember when you learn programming 2, you learn the concept of interface. So interface, if you still remember, it's actually referring to the methods. It is a kind of method, but that it does not have coding inside it, right? So basically, this interface is being used to describe what the components is, what the component can do. So it basically describing the functionality of that components, right? So that is referring to the interface. So that's related to component testing. Okay, system testing on the other hand is where the system is already combined and is working as a whole. So when you do system testing, you are testing a complete system, right? So at this point of time, the focus is more on to see how the component interactions, is it is the interaction done smoothly or not. Okay, let's look at the unit testing. Unit testing is not only referring to class level, but also it can refers to testing of functions and methods within the objects or the object itself in terms of attributes and its methods, and also composite component. So maybe there are several other components that are working together, and you want to see whether it can be communicated through the interface, right, to access its functionality. Alright, I mentioned that unit testing is very closely related to object level. So during unit testing performed on objects, you are basically testing the operations in the object. You want to see how can you set or interrogating the object attributes, the variables inside the object. Okay, so and then you want to see how the objects exercises different possible states. Remember, you have learned during design stage, design slides, design phase that we have covered in the previous content, there is a state machine diagram, right? So where it captures the states, so you can actually use that state machine at this point of time to see how the objects state of the object change, and that can be used for generating test cases, right? It becomes more challenging when you apply inheritance, because when you apply inheritance, you have superclass, subclasses, so there are more than one class. So testing it will be slightly more complicated, right? Let's say you have a class, an object, and it shows here object interface. So object interface is, you can imagine it as the method, right? It's just that for interface, the implementation, the coding for this method is not shown. Okay, so basically this interface or methods is describing what this class can do. Okay, so when you test it, you actually test the methods. Alright, so this is an example from the textbook for weather station testing, where it shows how to test that class just now. So when you want to do object unit testing, alright, you can actually define the test cases. Okay, you need to write down what to test, right? How to combine it with other methods, how to begin it, and then how to shut it down. Okay, all this start up, shut down is actually a mechanism provided by a JUnit testing tool. Okay, we'll come to that later. So having our state machine diagram, so you can actually use it because it's actually showing changes of states. So you can actually, the changes of states in that class, in that state machine diagram can be used here to identify the sequence of changing of states. For example, this weather state class is having this changing of states from shutdown, it is running, and then shut it down. So that's how you can test it according to this sequence, or you can follow this one. Uh, the state, the weather station began to start running, and then start to collect information related to the weather, then run again, and then summarize the data, and then transmit, and then running. So all this information is actually captured in the state model. Okay, so this state model is useful whenever they want to create the test cases, so that they know what are the sequences that they can test. Okay, normally when we do unit testing, we use some tools. Okay, um, in Java, if you use NetBeans and you use Eclipse, there is what we call it as a test automation framework. It's actually a kind of tool that is embedded in NetBeans that to help you to run your your unit tests. Because when you write unit tests, there are many test cases. Just imagine for one class, you can create many test cases for one class, and then in one system, uh, and in one component itself, there are many classes, so there are like hundreds of test cases, which is coded in Java. Okay, and we use JUnit, which is a test automation framework to run it. Okay, if like 100 test cases that you want to run, so there is a way of running it automatically, and it will collect the results, whether it's a pass or fail. All right, and then uh, it can be set up very easily, and you can just run it with one click. Okay, so okay, if you are using JUnit, there is a template that you can follow to set up the test cases. When you want to set up the test cases, you can actually identify what are the inputs that you want to put in, what is the expected output, okay, what method to be called, alright. And then in JUnit, there is this function which is called assertion. So this assertion is basically like a function that will compare. Um, let's say when you run the test cases, it shows different results from the results that you expected. So this assertion is basically like your if else statement that you normally write, so which help you to compare the results. Okay, when the results does not meet um, the one that you want, it will show fail. Okay, so just imagine there is like hundreds of test cases that you want to run, and you don't want you want JUnit to automatically check the results, whether the results shown on the screen is the one that you want. So we use the um, function called assertion. Okay, so assertion, you can imagine it is as your if else statement. Yeah, it is used to compare results. Okay, so in choosing unit test cases, there are two types that you can write. Okay, one is to reflect normal operation. Okay, you can write test cases to show its normal operation to see whether there is no error performing normal operation. And on top of that, you can also write test cases to break the system. Okay, normally this comes from the experience of the tester. Because sometimes after quite some time, the tester are very experienced and they know what are the the test cases that can break the system. Okay, then in this case they will use abnormal inputs. Okay, not normal inputs, but inputs that they think will break the system. Okay. Right. When you are writing test cases for JUnit, there are two strategies that you can choose. Remember, when you write test cases, you also have to think about the data that you want to use during the test. Okay, there are two strategies. The first one is testing strategy. The other one is guideline-based strategy. So with partition, the name is partition. So it is basically trying to group the inputs based on certain characteristics. Okay, so when you choose the test data, you choose from that group. You don't you don't simply guess the data. You actually guess it, but from a, a collection of a group of inputs. Or another one is called guideline-based testing. So basically, after quite some time, the software tester has some guideline that they follow. So this is based on the previous experience done by the tester, and they record it and then they share it with other programmer. Okay. So with partition testing, the input data that you use for testing and the results that you want to be appear in the test cases normally fall into into its own group. Okay, there are collections of data that you can choose from. Okay, I've mentioned just now that you don't randomly choose, you don't guess it without any guidance. Okay, each of these classes is an equivalent partition. Each of these class is actually um, a group of data that when it is being used, the program behave in the equivalent way. Okay, so test cases should be chosen from each partition. So graphically, it looks like this. Like for a system, there is a collection of inputs. Okay, that when you choose one data from here, it behave uh, in consistently. When you choose data from here, it behave in a consistent manner. So that is what it means by equivalence partition. Partition means group, and if you choose any one from here, it will give you equivalence, the same results. So when you choose your test cases, you can choose one from here, one from here, one from here, one. You don't have to test so many from here. So you are trying um, to be more effective. Okay. If you want to test, you choose from here, one from here, one from here, one from here. So that will be your test data. And then from the output also, you can choose one from here and one from there. Alright, so you don't have to test like looking at this diagram, you don't have to have so many output for the test cases. You can only have two. Okay. So by doing that, you are actually saving some of your time rather than testing everything possible inputs there. All right. Okay. Equivalent partition can also be seen like this. Okay. So let's say if you want to see the age of the students, for example, you can test anything between one data, anything from between 4 and 10, choose one data. Anything more than 10, choose one data. Okay, so if you have ranges of values like this, you can your test input can be 3, 4. So anything at the border, anything one from in the middle here, and also at the border. So rather than testing anything from so many inputs from here, you can test maybe a maximum of 5. The same goes here also. Let's say if you have, this is small numbers, right? So how about ranges of data, like this is 99,000, okay, almost 100,000. So you don't want to test every single data, right? So it's a waste of time. So what you need to choose, you choose one from this partition, one partition from here, one partition from here, and data at the border. Okay, so if you choose one from here, it will always return the same response by the system. Okay, looking at the second approach in writing test cases, in identifying your test data, so you can use testing guidelines. Okay, this is basically best practice done by the tester that they suggest. If you don't want to use partition, equivalent partition, you can use this. Right, you can test whenever you want to test. You test whenever, actually when you test a system, normally you have to put several data, but in this suggestion it asks you to only put one data and see what will happen to the system. And then when you try the data, you try with a different size. Okay, one is small data, and the next test cases use longer data. And then this one here, derived test, so that first, middle, and last. This is like equivalent partitioning. Okay, where you test the before, in the middle, and after. And then also test the sequence with zero length. Okay, you don't put any data there. And this is more like testing guideline, which is more general. It can apply to all sorts of testing. Okay, when you try to identify the test data, choose input that force system to generate errors. Okay, this comes from your experience. Sometimes you know which data that cause error, maybe very long very long name. See whether the system can process it. And also you design inputs to cause memory overflow or buffer overflow. Okay, repeat same input many times. Okay, you can also try it. So try you also purposely identify the test data so that it produce wrong output, and then you force results to be too large, too small. Okay, so basically these are all the strategy or guideline that you can follow just to break the system. Okay, you want to cause error to the system. All right, just now we have covered on unit testing. Let's move on to slightly bigger. As you go along developing the system are more ready, more classes have been there, and then they keep on combining it, and now it become a component. Okay, so component here not only referring to one component but composite of component, maybe several components. You want to see how they are interacting with one another. Okay, so at this point of time, at the component level, all the functionalities of the objects within that component are being accessed through the interface. Right? I mentioned interface is like a method, right? But the implementation is not there. It's actually in other objects. Alright, so basically you want to see how the component interacts with one another through the interface, and to see whether it is following the specification. Right, way of when you do component testing, you basically test the interface. Okay, you want to see whether are you able to detect fault due to the interface errors or invalid assumption about the interface. Okay, how you can do this? You can test the parameter. Okay, you pass data pass from one method or procedure to another. You test the parameter of the interface. You can sometimes the interface is actually share the same memory. You see whether how to create errors due to memory. And then procedure interface. Okay, so this is you want to see how the subsystem encapsulate a set of procedure. Okay, so sometimes within the component itself there are subcomponents. and they have a collection of procedures within it. So you want to see how it is interacting with one another. And then message passing interface, we want to see how the message are being called from one system to another. Okay, so you can imagine this is the component. Within it there are the objects, and these components are being accessed through the interface. So interface is basically the methods within that is supported by this component. So when you you create test cases, you cannot test things inside here. You are basically testing the way that this interface are being called in terms of this data, in terms of the way that they are sharing memory and so on. Okay, because when you are testing components, this part here is actually hidden to you. So you can only know about this component just by looking at the interfaces. Alright, among the errors related to interfaces is interfaces misuse. Okay, they because you cannot see what is inside the component, you basically depend on the interface. Maybe the way that you pass the parameter is wrong. Okay, because you cannot know what is inside the interface. So sometimes you make your own assumption. You are assuming what uh, uh, how the interface can be called. So along the way, maybe there are some misunderstanding, and some function maybe rely on time, and maybe the processing is too late that is no longer supporting it, right? So these are some of the guidelines on how to test the interface, right? You can test so that the parameter uh, is tested, the value using a very extreme value, and then always test pointer parameter. When you use object oriented, you are actually referring to the addresses, right? So see what happens if the object point to null value, and then you basically design so that the component is failed. You use stress testing, you pass the message in a high volume, okay, and then some of this we mentioned about shared memory system just now, right? So we try to test if you uh, put the ordering of component to be accessed the memory in a different order, so you see what will happen. Okay, so we have looked at unit testing, we have looked at component testing. So now imagine that the system is keep on growing, it has been developed, all the component has been assembled and integrated, making it ready for more ready as a system. So now we can form system testing. So system testing is done during development also, involving integrating of components to create a version of system, and then testing the integration of the system. So at this point of time, you can imagine there are many components. So more components compared to component testing. So more components, and we want to see how this component is communicating with one another. Okay, so system test checks the component. Are they compatible? Uh, are they interacting it correctly? Does it transfer the right data at the right time across their interfaces? Okay, so that is a slightly bigger scale of testing. Okay, so during system testing, there are, because this is at the level of system testing already, there are sometimes they don't develop the system from scratch. Maybe there are some other components that they have developed for quite some time, and they feel that it can be reused together with the system. So you have to test it with the reusable component, and we want to see how this reusable component is integrating with the new components, and then you combine it and then you test it as a whole. Okay, component developed by different team. Okay, sometimes if it's a large system, maybe some of the components are being developed by different companies, so you want to put it together and see how it works. Okay, at system testing also, another approach that can be used is use case testing. Remember, we have this use case diagram information that was being derived during requirement engineering and also being used during design, right? That information is actually useful in creating that, and it can be used during testing. So when your use case uh, diagram and specification are being used during testing, we call it use case testing. So it is actually a way of performing system testing. Okay? Each use case usually involves several system components. So you can use this to see how the components interact with one another. And the sequence diagram, remember we cover sequence diagram when we are um, uh, trying to capture interaction between objects. Is also associated with use case diagram because we want to see what components interact. Okay. So sequence diagram actually when we are looking it during at design phase previously was being shown at object level. So this one here is a slightly higher level of sequence diagram, but it is showing communication or interaction between the component. Okay, so if you have this diagram here, it actually helps us to write test cases for the system testing. Okay, we want to know this one is collect weather data sequence chart. Okay, so if you want to collect weather data, so these are the components which are involved. So what are the message passing between them? So this information can be used to generate the test cases. Okay, so you can derive the test cases from the sequence diagram. So an input of the request for a report should have an associated acknowledgement. So rather, because sometimes what happen is during system test, it is not the system test is not written by the developer anymore. It is being written by a tester outside of the development team. So having this sequence diagram actually helps them on how to generate a test. Okay, to recap what we have covered in this video is that we are looking at several stages. We are looking at uh, different types of testing that we can perform during development phase, where during this point of time, it is the responsibility of the software development team to perform the testing, and also in performing system testing, we can have a separate team that will responsible to test the system before it is being released to the customer. Then we will look at three types of testing just now: unit testing, component testing, system testing. Right, unit testing is basically trying to test individual objects or methods or different unit of program, whereby component testing is to test related groups of objects to see how they communicate with one another. We try to see whether there are problems during their interaction between the components. And in the system testing, we are trying to test it as a whole. Okay, we can use case testing as a way of performing system testing. And then when you are testing, you are trying to break the system. Okay, so in order to do that, we have to identify the test data. What kind of input do you want to put in the system in order to break it? So there are two ways, two approaches. One is to use partitioning, where you select the data based on the collection of uh, data which produce same results, which is called partition, or you can follow existing guideline written by previous software tester, giving you some tips on how to identify the test data, right, in order to discover defects in the system. And then I've mentioned earlier that performing unit testing is actually very tedious because there are many test cases and you need to manage all the test cases and you need to run it as a whole. Okay, and at the same time capture what are the results, whether is it pass or fail. So you can actually use an automated test tool whereby all this tool is just actually embedded with the programming environment that you are using. If you are using NetBeans, Eclipse, you can actually use a testing framework which is called JUnit. That's job is to create you a template for you to write test cases, and then it allows you to run all the test cases in just one click of button, and it's able to capture the results of pass and fail. Okay, thank you so much.